Hey everyone, I want to welcome you to the spooky edition of Math for the Impatient. We're here today with our CTO, Stan Kladko, and today we're going to talk about interchain token transfers, which is a hot topic for everyone. Super exciting to see a lot of things go live on the network, and this is a pretty important piece of technology. So we will start with the basics. What are interchain token transfers? Why are they important for the Scale network? I think those are two pretty critical questions.
Yeah, that's a great question, Marcus. First of all, I would like to take time and say Merry Christmas and Happy New Year to everyone. It's a really busy time at Scale Engineering. We're working hard on Scale Release 2, on Oracle, on threshold encryption, many other things, and in particular, interchain token transfers. And this is kind of beginning to be like a super hard subject because there are many chains. And as you guys know, Scale has many blockchains, and we need to be able to transfer tokens between those chains. Now, a very typical use case is a game. Users earn tokens in a game, and then they need to exchange those tokens at an exchange. We have a really wonderful exchange called Ruby Exchange, which is coming to our network. So people would want to play a game, earn some game tokens, and move them to another blockchain where Ruby Exchange runs, and then probably exchange them to USDC or some other stable coins. So that's a very typical situation. People use things on one blockchain, earn money on one blockchain, but then the exchange is on another blockchain. And the question is, how do they move their tokens? Now, Vitalik recently tweeted an interesting tweet. He, as many other people, he is studying this question, how to move money between blockchains. And he is pretty much tweeted that, it's dangerous and it requires lots of security to move money between blockchains. The way to understand it, I think if you understand that every single blockchain is a castle, then you can think about a movie like Game of Thrones and imagine that you need to move from one castle to another castle on a road. And the castles are secure, but nothing actually is secure on the road. So you need to actually have lots of dangers, and you may actually lose lots of things while you are traveling on this road. So the security is not automatically provided on the road. On the other hand, it's really important for you to have the road and to actually move from point A to point B. The same situation is actually now in the blockchain world. People understand that interchain token transfers are hard, but you need to do them, because we need to be able to onboard billions of people on the blockchain, and for these billions of people to be able to transfer their tokens. So it's a big issue, interchain token transfers. And it's also really important for us at Scale. And so we are working hard on this particular issue.
Awesome. So that brings us to the next sort of logical question, which is, how will Scale's interchain token transfers work?
Yeah, that's a great question, Marcos. And there are several people that ask me the same question on Twitter, and they ask me about other blockchains, in particular Cosmos and Polkadot, and people ask me whether our architecture is going to be the same or similar to Cosmos and Polkadot. And I'll explain in a moment why it's going to be different. So in Cosmos or in Polkadot, the idea is that you have this Uber chain, and if you want to transfer any token from point A to point B, you first go to this Uber chain, and then you go from the Uber chain to another chain. So there's a chain which connects all chains, and the architecture is pretty much like a star. You have the central hub and everything which goes to the central hub. This hub architecture scales well if you have like 100 chains, but it doesn't scale well if you have 1,000,000 chains. So imagine you have 1,000,000 chains, you have a single hub, the hub becomes really overloaded. Because at Scale, we are actually thinking about scaling to thousands and millions of chains, we can't really have this hub architecture. So we came up with architecture is more decentralized. And the way it works is actually every chain is a hub for its token. So If you are a game and your game uses a particular token, then you actually control the token and you are a hub for this token. And if I, for instance, have an NFT chain, then I'm a hub for my NFTs. So it's much more decentralized. Pretty much when you own your chain, you own your token, and you also a hub for your token. So your chain is a controlling chain for your token. And it's also important for security. I'll explain in a moment why. There are some security architectures which are really bad, and there are some which are reasonably good. As an example, let's take ATMs. You know that many people in the world use ATMs. There is cash in ATMs and US dollars, euros, all kinds of currencies in ATMs. And every day all over the world, people break ATMs, people bomb ATMs, do all kinds of bad things to them and extract money. Bank employees steal money from ATMs. So every single day you have some money stolen from ATM, from a particular ATM, but the world's financial system still survives. So the financial system has this limited damage property that if you damage any particular ATM and steal money, you will only have limited damage. Now, you could actually have a much worse system. Let's imagine you have a system where instead of ATMs actually holding money, there's a printer inside. And every time you want money from the ATM, the money is just printed inside the ATM. That would actually be much more efficient because you wouldn't need to refill ATMs. There would be just printers inside. And from this perspective, the technology would be great. But the system would have this global instability where if you would hack any single ATM, you would actually be able to print an enormous amount of money and essentially take US dollar down. So this architecture is bad, and the architecture that banks use now is reasonably good. So reasonably good architecture is where a hack or a compromise of a particular subpart of your system does not lead to the global compromise of the entire system. The same in our case. If you have many scale chains, and let's say you break a particular scale chain, the only damage that you will do, people will be able to steal money that was transferred to this particular chain, but they won't be able to affect money supply on other chains. So the actual damage will be limited. And that's really important for us because if we have millions of chains, we need to be prepared to a situation where a particular chain can be hacked. You know, if you have such a complex system, it's impossible to guarantee that any part of it will never be hacked, right? So we have to make sure that even if a particular chain is hacked, the damage is limited. And we actually came up with a solution which does this. You hack a particular chain, you only hack the application that runs on this chain and only hack the money which is on this chain. So the damages are limited. And this creates a really good story for our dapps. And then in our system, since there's no really a gas, so we don't pay for transactions at scale, the interchain token transfers are also going to be free in scale. So essentially, if you play a game, the way the users will see it, they will earn money on a particular scale chain, and then they will go and transfer this money to, say, Ruby exchange it to USDC, and be happy, all with zero transaction costs. Scale actually guarantees zero transaction costs because we don't actually have any transaction fees. We have something which we call zero fuel, which is just an imaginary thing. It's not really a cryptocurrency and doesn't actually have a monetary value. So to make a long story short, our architecture, after many discussions inside SKALE team, we came up with a really good architecture. This architecture is now running inside SKALE as beta. We are getting it QA'd and tested for the release, for the second release of SKALE. And also there will be another interesting thing. There will be a public competition. People will be able to try hacking our interchain token transfers. And there will be some possibly monetary prizes for this. So we're actually going to be opening all of this thing to our community. There's absolutely nothing not open source or hidden in our system. Our system is entirely open.
Cool. So, I mean, I think the last logical question is going to be, what are the kinds of dApps that you can enable by being able to do this?
That's a great question, Marcus. And I think the holy grail of like Bitcoin or Ethereum, whatever people think when they think about crypto, has always been being able to pay at any time to any person or to any device anywhere in the world for free, right? That's really what people wanted always. That's when Vitalik said, 5 cents per transaction is too expensive. It has to be free. So the dream has always been that you should be able to pay at any moment anyone for free. And it's totally clear that it's impossible to do it with a single chain, right? Because you have 6 billion people, but not only people, you could have so many other things. You could have devices, you could have cars paying for parking, so many things. So you're talking about billions of entities being able to pay to each other for free and securely. And the only way to achieve this will be to do it using multiple chains. So interchain token transfers are super important. So in the future, not so distant future, actually, with SKALE release 2, right? If you want to pay someone, you will just find out on which chain this person is, and then on which chain the money is, and pay this person for free. And the money you have in the system will be the actual sum of the money you have on all of the chains, but you won't actually have to care about this. The UI will hide it from you. So the UI will just show you, for the most part, the total money you have. The fact that your money will be scattered over different chains will be just implementation, interesting for engineers and nerds, but you will just see that you have your money and you can transfer to any person in the world money. And this will be instant, talking about seconds, and you will be able to have it on SKALE. So with SKALE, we are able, we can say now, with SKALE release 2, and by increasing the number of chains, without any other software modifications, we will be able, any person, any entity on the surface of this planet, at any time, any amount will be able to pay. And this is something that we really, really find interesting. And not only talking about money, but also some other transactions like creation of NFTs, for instance. It enables very different business models. If you are able to create an NFT and transfer it without thinking about paying for anything. And so people will be creating much, much more NFTs, transferring them. Some of them will never get any monetary value. They will be just fun things. Some of them will actually become, expensive or get some monetary value. But we're also talking about a very different model for NFTs, because the process of creation and transfer is free. And then so we hope that SKALE network or SKALEverse will actually enable many people try many interesting things for free and experiment with blockchain. And some of the things actually ultimately making money, some of the things just making fun and stuff. So it's actually going to be really, really interesting once we release SKALE version 2.
Very cool. Awesome. Well, thank you everyone for this week's episode. You can look down below by the kitty cat maybe, and see our Telegram, our Discord. Please join, please follow us on Twitter, and look forward to seeing you on the next episode. Thanks, Dan.
Thank you, Marcus.